Good afternoon. Last week we started talking about alkanes, and today we'll continue talking about a related class of molecules known as cycloalkanes. Just like alkanes, cycloalkanes are built from carbon and hydrogen and only have single bonds. But unlike alkanes, cycloalkanes have one or more rings, so closed loops of carbon atoms within their structures. Formally, starting with an alkane, such as this molecule of butane, we can construct cycloalkane by removing these hydrogen atoms and then moving these two valencies to bind with each other, giving a cyclic structure. So we would start from butane, the formula which is C4H10. Remember, this is CnH2n plus 2. And we end up with cyclobutane, the formula which is C4H8, and again this corresponds to CnH2n. So this difference in general formulas for alkane and cycloalkane is apparent, and it's pretty straightforward because in alkanes we basically have a series of CH2 units which are then terminated at ends with two hydrogen atoms. So this increases the total hydrogen count by 2. In cycloalkanes, on the other hand, we have a series of CH2 units, but since they're cyclic, there is no end to this molecule, and so we don't need two hydrogens to terminate it, so the overall formula is CnH2n. Members of cycloalkane class are also represented by line angle formulas as corresponding polygons, so it can be a triangle, which stands for a molecule of cyclopropane, a square which stands for cyclobutane, a pentagon which stands for cyclopentane, or a hexagon which would stand for cyclohexane. Now, alkanes and cycloalkanes share a number of similarities in terms of physical properties. So since they're composed of CH bonds, which have very small dipoles that also largely cancel each other out, they're very nonpolar. They're also relatively non-reactive because they don't lack functional groups. They're insoluble in water on account of their nonpolarity. And just like with alkanes, the boiling point and melting points of cycloalkanes increase with the number of carbons. The difference with, the common feature of all cycloalkanes is they're cyclic rings, so they're a little bit closer to spherical shape than a normal alkane is, which means that their boiling points and melting points correspondingly should be slightly lower than for alkane. So to summarize up this class of properties, they're insoluble in water, nonpolar, non-reactive, and their boiling points and melting points increase with carbon count.